So let me remind you, well, we'll cover this as we go. Did everybody else get their script to run to the point where they're at the end? We got one student still working through it. Yeah? Okay, cool. So what we did last time was we just did a really simple simulation where we essentially replicated what you did in your homework on the computer. Why would we do that on the computer? Well, because if you can do something simple on the computer, you can do something complex on the computer that is just the same thing ramped up. And so what we want to do is we want to build things up to the point that we can do bigger simulations using these same kind of tools. So the first thing that we want to do today is we want to take that one card deck that we had and we want to make it big. You guys ever been to a casino? Oh, okay. You ever play a card game at a casino? Okay. When you see the blackjack table, how are their cards set up? Is there one guy dealing from a pack of cards in his hand? Really? Yeah, he has a whole yeah, is that what they call them? They're typically about 7 decks deep. And the reason is that discourages people counting cards. Um, and so what you have is you have a combination of 7 decks. So it's very difficult to keep track of how many aces, kings, queens, et cetera, have been dealt because the card decks are that deep. And even before they finish running that multi-card deck out, multi-deck shoot out, they'll change those out periodically before you've exhausted all the cards. And so what we want to do is do the same thing in statistical terms. So what we're going to do is we're going to set up a new set of cards. So recall that the old card deck that we had was just called card. So that's still referenced in there. What we want to do is make a new set of cards where we basically take replicates of that same card, and we're going to get 50 copies. Now, if we do this 50 times, we should end up with 13 cards times 50, which would give us 650 values. So we can check whether it did that correctly, not by printing out all 650 lines, because we're really not interested in that. We're just interested in whether or not it did it. So we can actually look at the structure of cards to see if it did it. So I've put a S on this to make it plural to separate it from card before. So let's run the repetition and get the structure. And when we get the structure, we see that there are now 650 values in this data set rather than 13 values. So structure is really useful because it tells you what's in the thing that you just did. So oftentimes when you ask me to come over because you've got an error or something, I'll ask you to give me the structure of the data that you're working with because we can quickly tell at a glance what's going on there. Hannah, right? Haley. Hannah. Okay. Haley, when you called me over because your script wasn't running, I saw that was V1 and V2, and you were trying to add draw 1 and draw 2 to one another. So just running structure told me exactly why your thing wasn't running. Same thing with your thing. It was easy to see, oh, you're asking it to do average with a small a, but you had saved it as average with a big A. So either taking the head of a data frame or taking the structure of a data frame will often allow you to see your data well enough that you can diagnose what's going on. So after I get the computer to do something for me, I will oftentimes check it with something like taking the head or the tail of the data set or looking at the structure of the data set. Are you with us? Did you run your script and it ran okay? Okay, cool. So now we have this big set of essentially 50 decks of cards. And so what we want to do is we want to now sample that. So we're going to make a matrix, and I'm just going to call it mat to save myself a couple of keystrokes. And this is going to create a matrix, and the matrix is going to be constructed by sampling cards. And in this case, let's do something small just to make sure that it works. We're going to sample cards 100 times, and we're going to replace the cards as we sample them. And we're going to put these results in rows, and we're going to do 50 rows, and we're going to do 2 columns. It's in call, not in calls. Let me make this bigger so you can see it all the way out. And then once we're done with that, we're going to take the structure of that, because that's one good way of doing that. So assuming that I've typed that in correctly, it should, no, in row, yeah, in row is not an S on the end of it. There should be a parentheses after replace equals true. Once again, I'm getting this by looking at the error. Basically, what it's telling me is that it couldn't go past replace equals true. That's what this error is saying. So it didn't recognize in row and in call. And so the reason is that I didn't close that parentheses that started with cards. So the sample command, it's asking you to sample what? Well, sample this thing, sample this many times, replace as you sample, and then that's done, so you have to close that off with parentheses. Still have too many parentheses at the end. Parentheses are the bane of my existence. Thank you. Okay, now what it's done is it's told us that we have 50 rows, 2 columns, and these are the data that are in them. And that's all we really asked it to do. We asked it to generate 100 values and divide it into 2 sets of 50. Draw 1, draw 2. So we've basically taken 2 card draws 50 times now rather than 10 times, which is what we did a few minutes ago. Once again, you'll see that this is just a bunch of numbers. So we need to get this into actually, we can just work this as it is. So they're in 2 columns. So the way you get, you can get the average of 2 columns. We'll just call this average with the assignment letter, and we can just get row means because we have this organized as a matrix from the last command. Row means of the matrix, and dimensions equals 1. And row means should have a capital M. And then we can, once again, check that by taking the head of that if we want, just so we can kind of look at the values. The reason it's useful to just look at the values is because we see that these 0.5s are in here, and if we've taken an average of two values and it ends up being an odd number, when you take the average, it'll give you a 0.5. So we've basically done that, but once again, if we look at the structure of that, it's just a bunch of numbers, and that's sometimes a little more difficult to work with. So let's convert that to a data frame. How do we do it? How do we convert something to a data frame? As dot data dot frame. Yep. So we're going to take this thing, use the assignment operator to as dot data, and once again you can use tab complete, and we're just going to take that same thing and convert it to a data frame. Check its structure again to see if it did it, and when it does it, it should have it as a data frame. And then we might want to know what the average value is of that. So notice that this is the data frame AVE, AVE, but then the column, the variable is also AVE. So we would have to have the data frame and the column heading to get the mean of that column. So execute that, and we see that the average is 6.31, which is close to, but not exactly, the expected average of 7. So 6.3 is close to 7, which is what the expectation would be. But of course, we only have 50 means that we've averaged up. We can get the standard deviation of this if we want. Sorry. The command for standard deviation is SD. And so the unfortunate thing is you can't assign variables names that also correspond to functions that already exist in R. So it would be nice to shorthand standard deviation SD, but because SD is already a function in R, you can't do that. So that's why I'm calling it stdev. So the standard deviation here is 2.624239. And this will become important here in a little while because one of the things we're going to do is we're going to generate bigger data sets, and we're going to want to calculate what the standard deviation of that data set is for graphing purposes. And so now that we have all of that, we can basically just make a histogram. And so we can make a histogram, we'll call it histo. And we'll use the function hist, which is already in R. And we want to plot the column av within the data frame av. The breaks are going to be 14 because we have 13 different values. And the x limit is 1 to 13. And so, oh yeah, equals C. This is the problem when you're talking while you're also scripting, is it just doesn't always work. And I left out my equal sign. Kind of like walking and chewing gum. So when you run that, it should the assignment operator didn't work. So just don't assign it to anything. We're not going to use this beyond this. We're going to do things a little differently from here on out. So when you run that, it should give you the histogram. And you see, it doesn't really look like a normal curve yet. And the reason that it doesn't look like a normal curve yet is because of two things. One reason it doesn't look like a normal curve is we only have 50 trials. The other reason it doesn't look like a normal curve is that each of these trials is a sample of 2 draws from the card deck. Okay? So if we increase either the number of draws that we take from the card deck each trial, or we increase the number of trials, this histogram should begin to look more and more like a normal curve. So let's do that. So let's do 1,000 trials. 1,000 trials, drawing 2 cards each. So in this case, what we want to do is we want to take a matrix, but a much bigger matrix. So I'm going to call this mat2, since it's a matrix for 2 card draws. And what we want to do is we want to create a matrix. From that matrix, we want to sample. In this case, we want to sample 2,000 times. We want to still use replace equals true, even though it shouldn't really matter at this point. And we want to put those into 1,000 rows and 2 columns. And once again, I have parentheses issues, but I just fixed that. So sample, then cards, times equals 2,000, replace equals true. You could put times equals 2,000 like we did up here. Oh, we didn't do that up there. We did that earlier in this. But you could also put replace equals t for true. It will all work the same way, and that way R is pretty flexible. So let's see if that runs. Once again, get the structure of mat2 to see if the structure looks right. And what we see is we have 1,000 rows and 2 columns. Is everybody there? I forgot to give out stickies so I can monitor where you're at. Yeah, what you got? Okay. This should be, so this should be a parentheses. So parentheses, and I'm not sure, put a parentheses there. I'm not sure what that 2,000, that first 2,000 is for. So you're sampling cards, 2,000, replace true.
Oh, okay.
Yeah, so you have a 2,000 out in the front here that doesn't need to be there. See if that does it for you. Oh, that's the histogram that's generated? Woo, that's a stinker. So you skipped ahead and generated the histogram? Oh, that's the last one. Okay, no wonder it looks so non-normal. So as always, green post-it notes when you have finished the thing that we just did, and pink ones when you hit a snag. All right, everybody with me? Okay, cards down. So we have this matrix. So the first thing that we have to do is we need to get, once again, the row means. So we can just use row means, and we'll once again put this in a new object. So before you do this, let me type it out. So keep in mind that what I've done now is I've made a matrix, but rather than hold on to this matrix, which has more information than I really want or need in it, I'm going to create a new object, av2. It's a new object different from the matrix that we just created that's just going to have the row means from mat2. So mat2 is still in there somewhere, but now there's going to be this new thing, av. When you want to know what kinds of things that you have created in R, you can come over here and look in your environment, and you can see all of the stuff that you've created. So I've got a bunch of stuff that you don't have, but among them, I have av2. We're going to do 5, 10, 20, and 30 before this is all said and done with. But mat2 is still there. And also, the thing that it shows over here is it also shows the structure. So if you want to, you can still continue just typing in the structure command to get it to appear over in your console. But the other thing you can do without doing that is as soon as you create something, it will appear over here and it will give you the structure of it. So let's run this line and see if it actually does that. Let me clear out my history here so you can see. So as soon as I execute av2, Oh, it's because did I not do this? Ah, and you just saw me make a crucial mistake. In clearing all of that out, I got rid of everything I had done in this session. So just give me a minute. So now you should see AV2 appear there. Once again, at this point, it's just a string of numbers. It's just a numerical value. And of course, what we're going to want to do is we're going to want to convert that into a data frame. And it should be AV2, not AV, because I want to keep the different sample sizes separate. And what you can see now is we've created AV2. It's replaced the AV2 that we had before, and now it's a data frame with 1,000 observations in one variable. It's no longer a numerical string. It has structure to it. At this point, we can calculate the grand mean. When I refer to grand mean, a grand mean is just a mean of means. It's the mean of everything. And so this is actually just going to be taking the mean of everything that is in AV2 data frame and AV2 column. And let's check and see what that grand mean is. Since we're taking 1,000 samples of size 2, this mean should be closer to a mean of 7. And it's 6.923 now instead of 6.3. So that's closer to the mean of the expected mean of 7, largely because we've taken just tons more samples. The more samples you take, the clearer an idea you have of where the population mean actually is. There are some other things that we might want to know about this data set. For example, we might want to know the standard deviation. Once again, just use the SD command. And check to see that it gave that to you. And in this case, the standard deviation is 2.54. And before, the standard deviation was 2.57. So it hasn't really improved the standard deviation much. Once again, because we only have an N of 2. So remember that I told you that the empirical rule, what does the empirical rule say? From last week? What does it tell us about a normal curve? So 68% of the data will occur within plus or minus 1 standard deviation of the mean. 95% will be between 1.96 plus or minus standard deviations of the mean. And 99.7 will be within 3 standard deviations of the mean, plus or minus 3. So the reason that we're calculating standard deviations is we might want to plot on a graph where the mean is, the grand mean is, and where the standard deviations are of this data set. So we can see what the effect of more intensive sampling has on not only our estimate of the mean, but also how much variation there is around that mean. So let's set a couple of things up. So Here in a few minutes, we're going to be using a statistical function that is already built into R. And the statistical function needs to know two things. It needs to know the sample size that we're dealing with, and it needs to know the bin width that we're dealing with. And so we're just going to write these out and save them so that we can use them later. So we're going to use those things to now make a plot. And so we're going to call this plot P2. And the reason that we're going to call this plot P2 is because I want to reference it so I can just call it up at will later on in the day. And we're going to use ggplot. And we're going to be plotting data in the data frame av2. And the aesthetics for this is that the x variable is av2 within that data frame. And we also are going to want to identify bin width here at the beginning because we're going to be doing a histogram. Put a plus at the end of that line. Put in a theme. Command to get rid of all the shading and stuff that ggplot likes to do if you don't turn that stuff off. Now I'm going to do some things that we haven't done in the past. I'm going to add some labels to the graph just so we can identify what we're dealing with. So xlab is how you identify x label, put it in quotes. And in this case, we want mean of card draw 2 cards. Put a plus at the end of that line. We'll do ylab for y label. And in this case, it's just going to plot the frequency of the cards at each of those things. Put a plus at the end of that line, go to the next line. Now we're going to want to make a histogram. So in ggplot, if you want a histogram, it's geom histogram. If you want a scatter plot, it's geom underscore point. If you want a regression line, it's geom underscore what is it for that? Drawing a blank. Anyway, there are a bunch of, you can just type in geom area bar, box plot, column contour. There are all these different kinds of plots, and you get them as a result of calling up geom underscore. And in this case, we want geom underscore histogram. And this is where we need bin width. And so in this case, bin width is just bin width. This tells you how narrowly divided up your bins are going to be that your data are going into. We're going to fill those bins white, and we're going to color the boundaries of them are going to be black. Go to the next line and scale underscore x underscore continuous is basically telling us that it's a continuous variable. And in this case, what we need to do is we need to I made a mistake. Color equals black. I hit the wrong button. Scale x continuous. And in this case, we have to put in the breaks, how we're going to break up the x-axis equals a sequential set of numbers from 1 to 13 in 1 unit increments. That's what that's saying. And then the limits to this are going to be, this is just telling us what we're bounding our figure at, 1 to 13, because that's the number of numbers that are in the card deck. So this is basically saying we have a continuous x-axis. We're going to break it up into 13 segments, 1 unit each, and the limits, the boundaries on the x-axis are going to be 1 to 13. And then we have one last thing here, theme underscore, whoop, sorry, theme. This is just going to be a simple theme statement. Panel.grid.major. Of course, it's spelled wrong. An element blank, because we're going to get rid of the grid. It would normally add a XY grid, and it just looks sloppy. And you can have them if you want. It doesn't matter. It doesn't change anything except just kind of the aesthetics of it. And you can get rid of that grid on the minor axis as well. And I think that's all. And then when we're done with that, we're going to want to call that up. So when you finish typing all that mess in, run it and see what went wrong. Breaks. And so many times my mistakes are just typing mistakes. So you can see that I've done something wrong. It's not calling up the figure. So what I will oftentimes do is run this one segment at a time to diagnose things. So it's scramming at the very beginning. ggplot. Okay. It looks like I've done everything right, but it's still not. Are you guys getting the same error I'm getting? No. And you have exactly what I've typed in? That shouldn't matter. I mean, I a lot of times will do that in my final code just because it makes it a little more readable, but it shouldn't matter. So this is when the internet is your friend. So you can take any error message and type it into um, your web browser, and there's a place on the internet called Stack Overflow, and it's where you get people who had similar problems as you. Okay, that fixed it. Earlier today, I was exporting a R Markdown document, and that might have messed up my graphics engine. So what you should have seen when you did this is basically you have a distribution of points that looks a little more normal than it looked before. And does everybody have this figure? Right. Who doesn't? All right. What's your error saying? Element blank. Element blank. Element band. Yeah, that's a spelling issue.
Actually, I realized you have the same error, so it was just have the missing tariff.
Oh yeah, don't worry about those. Everybody else good? Yeah. All right. What you got? So run that. Where's your error from that?
I think it's right here. This stuff will run.
Okay. So add the next. So, well, that's not going to run by itself because there's nothing above it. You have to grab everything from there down to the end of that. Yep, not the plus though, because the plus is going to want you to go to the next line. Okay, and that just now do P2 because you highlighted P2. Okay, so that's giving you a blank histogram. Why is it? What's going on in your console? Where is this coming from?
I have no clue.
That's way up at the top. All right, let me hop in here for just a minute. Okay. Escape. Try that again. Okay. So you defined this. You ran these up here earlier? Bind width. Oh, it's a spelling error. There it is right there. Okay, something's still not happening. What did I do? I didn't highlight the whole thing. Ah, there it is. So now you should be able to just do the whole thing and the whole thing. So Skelet's continuous breaks. And it's all about getting all of the arguments correct. So now you've got your breaks. So now we should just add that, and it should be fine. Okay, cool. Yeah. What you got?
I think it's running, but I'm not getting data.
Okay, breaks should be breaks with a plural. Yep. Let's see. Try that again. All right. Let's see. Let's look at the errors. Oh,
I
it
don't
just hit
think
it. Okay, there are no errors. It's just your
Oh,
color
there we
scheme.
go. Oh,
Yeah.
thank
Okay. Cool.
thank you.
All right. All right. Everybody together. Good. All right. Cool. So we have a histogram, but it might be nice to plot some things on this histogram. And so let's add something to this histogram. So we're going to keep the name P2 because we want to refer to this later. So we're going to overwrite P2. We're going to take the P2 that we've already made, but we're going to add to that some stuff. And the stuff that we're going to add is some statistical stuff. So there are statistical functions that are already loaded into R. One of these is stat underscore function. And what this is going to do is it's going to allow you to create a normal distribution based on the parameters for your data set. So you've already calculated the grand mean, you've already calculated the standard deviation, you've already stored all of these things in R. So all you have to do now is reference those things. And so the first thing that you need to do is we're going to do function x dnorm is just going to give you a normal distribution. And in this case, it's the x variable, and the mean is equal to grand mean 2, because that's what the mean of the means is. That's the overall population mean. And the standard deviation, SD, is equal to STDEV2, standard deviation 2. And in this case, you do an asterisk, and then you put in what the sample size is, and you've already added that the sample size is 1500 up there where you've specified in and you specified bin width. And then the last thing that you're going to do is put in the bin width function, and now I need a wider screen. Tell it what the bin width is, and then you're going to give it color equals red. And you can change the size of the line. Hold on, let me get this so you can see it. And you can change the size of the line with the size command. And I just have it at 0.75 because that was easy enough to see. So, and I'm getting errors. Double quotes typically. And after standard deviation 2, you need to close that parentheses. That's why I was getting an error for starters. Let's do this. And size equals not in quotes, stupid quotes. I'm still getting an error there. Ah, that's the problem. It's the comma. Get rid of the comma. And I have an unmatched parentheses somewhere, looks like. Okay. So you can also put returns in to make it easier to see. So let's see if that did it. No, it didn't do it. Sorry. This is, once again, the problem with talking and going back and forth. There should be a fun in front of function x. Okay, all right. So let me see if I can make this a little more readable. Okay, so this is the function. I made a couple of mistakes as I was typing it in. Fun identifies what kind of function you're working with, so you're going to be running a function on the data that is the x variable, which in this case is av2. You're going to be calculating a normal distribution based on the x value, the grand mean, and the standard deviation, giving you 1,500 sample size, the bin width, which is the same bin width that we've had, and then coloring it red and giving it a particular size. So has everybody got this after all my miskeying things? Yeah. Okay, so let's see. So P2 should still be there, right? Oh, except that you've overwritten P2 now. For starters, let's just, it shouldn't matter. Oh, let's run this again. Make sure that it's still giving you that. Okay. Okay, all right. Had you run this before? You did, because we ran it just a minute ago. Yeah, so when that happens, sometimes I'll just go back and rerun that thing when I'm adding something to something else. Everybody else? Good? Okay, so now you should have a... Oh, sorry. I didn't see you. Okay.
At first I had this spelled wrong, and then I
Okay,
fixed it,
that's
and
fine.
it said
Yep.
like
Go ahead, me.
right there, but then I keep rerunning it whenever it's correct, and it's not. Like it still says that I'm spelling it wrong.
Go and run this section first. That should just give you the histogram. Okay.
Oh, thank you.
Yeah. Don't ask me why it does that.
It looks very different from yours, so like my lines.
Oh dear. Okay. So, did you run? You ran all of these things up here, correct? Mm-hmm. Well, let's run them again just to make sure. Yep, that's that. Okay. That's your histogram. Oh, interesting. 15. 1,500. It's only giving you 15 observations. So run that again, and then just now run P2, and then the next one. Next. Yeah, there you go. As a matter of fact, I had to play around with the sample size a little bit because in theory, it should be the number of samples that you have in there. But when I put in n equals 1,000, the normal curve was too low once again, so I just added 15 and put it in at 1,500. Yeah, that's the reason for that. All right, so we got this. Okay, so we're going to add some other things because this just shows you the normal curve, but it doesn't show you where the standard deviations are. So what we're going to do is we're going to overwrite P2 again. And in this case, we're going to take the P2 that we've already generated. We're going to add to that a bunch of lines. So geom underscore v line gives you a vertical line. And so we want to just draw a vertical line at the mean. And so for this, you need to know what the x-intercept is. And the x-intercept, in this case, equals the grand mean 2. And we want to color this red. And we want to add other things, so we're going to do some more geom lines. So we can actually type them out, or we can actually just copy and paste. So copy that, paste a new one, and in this case we want the grand mean, but we want plus the standard deviation too, and we'll make that one, for example, blue, and that'll give us the upper standard deviation, one standard deviation away, but then we need copy that line and paste, but we now need the lower one, so we would subtract from that, and we'll keep it the same color blue. And then we want to know what the 95% confidence interval is, so we'll keep that here as well, except in this case we want to just multiply the standard deviation times not 2 but 1.96, because that's the theoretical, times the standard deviation above the mean, and then we want to do the standard deviation below the mean, but once again we want 1.96 times that. And then at the end you want to get rid of that plus. So one of the ways that you can avoid making typing mistakes is once you have something written and you have it hopefully written correctly, just copy and paste things. And let's make these 95% confidence intervals black so we can see different colors. And when you run that and then call up that figure, you should now get a figure that shows you that you have your distribution of data. It conforms roughly to a normal curve. The grand mean is red. The upper limits of one standard deviation and lower limits of one standard deviation are in blue, and the 95% confidence interval is in black. Put your green sticky up when you've got that. So it moves faster once you have something that's kind of built already. You can copy and paste and just make those little small alterations and get the thing that you're looking for in the end. Now, one of the things that you'll notice is that those 95% confidence intervals are really wide. They span the entire, almost the entire range of the data. And the reason for this is that your sample size is a sample size of 2. All right, looks like you got it. Everybody's got it. All right, green stickies down. Okay, so we've done that for a sample size of 2. In your assignment, it tells you to do this for 5, 10, 20, and 30 as well. So let's start down that path. So now we want to do 1,000 trials, sample size 5. So we don't have to go back and reinvent the wheel. We've already done a lot of this. So come back up to this section here, copy all of this from Mat 2 all the way through the end of the figure, and paste it on whatever line is right below this new heading. Whoa. It helps if you copy before you go to paste, so you don't just repaste the graphics line that you had up there a few minutes ago. So once you've copied that, go back to the top of that little section, and we're just going to be changing things. So now, because we had Mat 2 for sample size of 2, let's change this to Mat 5. In this case, we want 1,000 trials of size 5. So we still need 1,000 rows, but we need 5 columns. And because we need 5 columns of 1,000, we need to sample our card deck 5,000 times rather than 2,000 times. We'll get the structure of Mat 5. Now at this point, I think everything else we need to change is just replacing a 2 with a 5. So with your cursor at whatever line you're at, which in my code is line 122, where you have structure map 5, go up here to edit and go to replace and find. And what we're going to do is we're going to find the number 2 and we're going to replace it with number 5. Now, you don't want to do this indiscriminately because there may be some 2's scattered in there that you actually need that aren't just identifying that this is sample size of 5. So one at a time, look at what is highlighted. When you activate this, it's found the next 2. If you want to replace that with 5, then just click replace. Do not click replace all. The other thing is you don't want to go through it too quickly because when you get to the bottom of your graphing block, if you keep clicking through, it's going to go back to the beginning of your script and continue working through. So you just want to work down to the bottom of your script. So examine each 2 and make sure that it's a 2 that you want to replace with a 5. Now we do want to change that 1500 to 1000 here in a minute, but we'll do that after we have. So here's in bin width, here's the 2 that you do not want to replace with a 5. So skip that one. So just go to next. Then you can replace av2 with av5, p2 with p5, av2, av2. This is now drawing 5 cards, so we can change the graph x-axis. p2, p2, p2. Grand mean 2, standard deviation 2, into P2, 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 grand mean, standard deviation, grand mean, standard deviation, grand mean, standard deviations, da 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 da. Okay, so now you see that it's bopped us all the way back up to line 4, and we don't want to do that. So you can just close that down so you don't accidentally replace something. Now go back to your P5 and change N5 equals 1000. And once again, I arrived at this just through trial and error. So now we've altered our script. So assuming that you didn't mess anything up through all that, you should be able to just run through this line by line, pay attention to the errors, but at the end, oh, but wait. This way of graphing things, the way I've shown you, where we basically make a part of a graph and then we look at it to see that it worked, and then we make another part of a graph and we look at that to see that it worked, et cetera, et cetera. You don't actually have to do that. That's a good way to build graphs up when you're building a graph for the first time. But you can also eliminate some of the clutter by basically just getting rid of these intermediate steps. So at what is my line 148, after the first graphing block, I'm going to delete the P5 to call that up, the next P5, and the first part of that, and I'm going to delete those, go down to stat function, and return until you get it up onto the line that is theme panel grid major, put a space and a plus, and hit return. Get rid of these preliminaries here, P5, P5, the assignment editor, and the next P5, and once again, delete space until you get to that line. So now what you've done is you've taken all of those individual spots, all those individual segments of graphing block, and you've just put it into one monster graphing block. So I just combined what we had first within the stat function within all those vertical lines. You look puzzled. Yep, get rid of that. Get rid of that. Now go down. Yep, there you go. Now you need to get that onto the, yep. So what you need to do is look over here at the far right. Every line needs to have a plus at the end of it so that it continues the code. Yep, there you go. So check all your lines. And then, so run all of that after you've made those modifications and see if it gives you a figure for P5. And I will do the same. Except I need to see my console. So what you should see at the end, if everything worked all right, is you should see a new histogram. Once again, the grand mean is still at around 7, but your one standard deviation is narrower. Your 95% confidence interval is narrower than it was in the last one. And the reason that it is narrower is because you're now taking samples of card draws of 5 rather than card draws of 2. Those 3 extra cards gives you a better estimate of what the mean is, and it also makes each card draw, each set of card draws, less variable from one card draw to the next. Do you think you can replicate this for card draws of 10, card draws of 20, card draws of 30? Okay, good. At the end, what I want you to do is I want you to, after you do all of this, we've saved P2, P10, P30, P5, P20. We've saved all of these. At the end, I want you to load RMISC if you haven't already loaded RMISC. So write this down. When you load RMISC, it will allow you to do a multiplot. And the way a multiplot works is it basically will plot lots of graphs in the same plot. So you can make yourself a really nice graphic by doing multiplot. And the whole reason that we've named these graphs individual names is so we could do this multiplot at the end. And the way multiplot works is it graphs figure the first one, then the second one, then the third one, then the fourth one, and the fifth one, if you've told it to plot it in 2 columns. So it plots down and then it plots by column. So for this, we want to have P2. We want P2 up here. We want P5 here, P10 here, P20 here, and P30 here. So we're going to put the order of plots P2, P10, P30, and then P5 and P20. And we're going to want those to appear in 2 columns, cols equals 2. If you run this at the end, what it should produce for you is something that looks like something that looks like this. And when you look at this, you see that each distribution gets more and more narrow as you increase sample size. Also, the 95% confidence intervals decrease as you increase sample size. So it'll produce a nice plot for this. And your task is to understand the relationship between sample size and the size of this 95% confidence interval. The more samples you have, the better idea you have of what the population mean is, and the less variable each sample is from other samples, and that's illustrated in this exercise. So homework for Wednesday, which is now actually due on Wednesday, is to finish this R script, adding sample size 10, sample size 20, sample size 30, produce that graph, and then answer the questions that are in the homework. All right, we just ran over about a minute. If you could, comments on the green and red sheets, clean up your desks, and hopefully today was a little faster than it was earlier, but we need to be speeding up. We should be getting more comfortable with R, and hopefully we'll be getting stuff done.